In this session, we will discuss about convolution of two functions. Suppose f and g are two functions of t, then convolution of f and g, that is denoted by f star g, is read as convolution of f and g. Convolution of f and g is defined as integral 0 to t f of tau g of t minus tau d tau. Tau is a variable. So, first consider, find the convolution of 1 and minus 1, that is denoted by 1 star minus 1. That is the definition. 1 star minus 1 is equal to integral 0 to t. Here, take the first function f of t as 1, second function g of t as minus 1. Okay, so f of 2, if f of t equal to 1, what is f of 2? It is a constant function, therefore f of 2 also 1. Into g of t minus tau. G of t is equal to minus 1 constant function, therefore g of t minus tau is also minus 1. Therefore 1 into minus 1 d tau. That is equal to integral 0 to t minus d tau. Integrating with respect to tau, it is tau. Varying from limits minus tau 0 to t, that is equal to minus of t minus 0, that is equal to minus t. Then second one is find out the convolution of e raised to minus t and e raised to t. So what is the first function f of t? Take f of t as e raised to minus t, g of t as e raised to t. Therefore convolution of e raised to minus t and e raised to t is equal to integral 0 to t f of tau. F of t is equal to e raised to minus t, therefore f of tau is e raised to minus tau. G of t minus tau is, g of t is equal to e raised to t, therefore g of t minus tau is e raised to t minus tau. G of t is equal to e raised to t, therefore g of t minus tau is equal to, replacing t by t minus tau, is e raised to t minus tau d tau. That is equal to integral 0 to t e raised to minus tau into e raised to t minus tau. What is x raised to m into x raised to n? X raised to m plus n. Therefore e raised to minus tau into e raised to t minus tau is equal to e raised to t minus 2 tau d tau. Is integrating function with respect to tau. That is e raised to t minus 2 tau divided by integrating with respect to tau. Integrating with respect to tau, t is constant. Therefore derivative of t minus 2 tau is equal to minus 2. Derivative of t is constant with respect to tau, and the derivative of minus 2 tau is equal to minus 2. Applying the limit 0 to t, it is minus 1 by 2 into e raised to t minus tau is replaced by t minus e raised to t minus 2 into 0. This is equal to minus 1 by 2 into e raised to minus t minus e raised to t. Okay, this is the final answer. Then next concept is convolution theorem. We know that convolution of f and g is integral 0 to t f of tau g of t minus tau d tau. Then Laplace transform of convolution of f of t and g of t, that is convolution theorem. Suppose L of f of t is equal to f of s, and that is Laplace transform of f is capital F of s, and Laplace transform of g of t is g of s. Laplace transform of f is f of s and Laplace transform of g is g of s. Then the Laplace transform of convolution of f and g is equal to f of s into g of s. That is Laplace transform of f into Laplace transform of g. So L inverse of its inverse function, that is L inverse of f of s into g of s is equal to f of t star g of t, that is convolution of f and g. So it is very important. So in some university questions you have to find out the inverse Laplace transform using convolution theorem. That is L inverse of using this convolution this is a convolution theorem. Using convolution theorem we can find out the inverse transform is L inverse of f of s into g of s is equal to convolution of f and g. So look at the first question. L inverse. So find out the inverse Laplace transform of 1 by s into s minus a. So it is of the form L inverse of f of s into g of s. Let f of s is equal to 1 by s minus a and g of s is equal to 1 by s. So it is of the form L inverse of f of s into g of s. What is L inverse of f of s into g of s? It is equal to f of t convolution of f and g, where f is the inverse transform of capital F and g is the inverse Laplace transform of capital G. Since we took L of f of t is equal to f of s, therefore small f of t is equal to L inverse of f of s, and L of g of Laplace transform of g of t is equal to g of s, therefore inverse transform of g of s is g of t. So first we have to find out f and g. So L of f of t is equal to f of s. Here f of s is equal to 1 by s minus a. Therefore f of t, applying inverse on both sides, we get L inverse of 1 by s minus a. It's a standard results. We know that the Laplace transform of e raised to at is 1 by s minus a. Therefore its inverse transform of 1 by s minus a is equal to e raised to at. Basic transform. Similarly, L of g of t is equal to, take it as g of s. Here g of s is equal to 1 by s. Therefore, small g of t is equal to L inverse of 1 by s is equal to, is also a standard form. Therefore, we know that the Laplace transform of 1 is 1 by s. Therefore, the inverse Laplace transform of 1 by s is 1. So, our g of t is 1. Next we can apply, that is L inverse of f of s into g of s. Using convolution theorem, it is f of t star g of t, convolution of f and g, that is equal to integral 0 to t. Here f of t is equal to e raised to at. Therefore what is the convolution theorem? It is f of tau g of t minus tau d tau, that is equal to integral 0 to t. F of t is equal to e raised to at. Therefore f of tau is e raised to a tau. G of t here g of t is equal to constant function 1. Therefore g of t minus 2 is also 1 into 1 d tau. That is integral of e raised to a tau with respect to tau, that is e raised to a tau divided by derivative of a tau with respect to tau is a, varying from limit 0 to t, that is equal to 1 by a into e raised to a t divided by s. We take 1 by a outside, therefore e raised to a t minus lower limit is e raised to 0. Therefore e raised to a t minus e raised to 0 is 1 divided by